GNG, General Next Generation, welcome to Mathematics. Traveling graphs. Traveling graphs, Sakati Chapa model. Yes, Sakaita graph, here meters per second. Here time edu, this is speed. This is T, our time in seconds. This is the motion of a graph. Like this one. So, from here, I can describe this as my initial time, also as my initial velocity, starting point, right? Here to here, the object is accelerating, right? From here, the object is moving with a constant velocity, constant speed throughout here. I'm join here. This is what we call constant velocity. Then from here to here, the object is decelerating. The object is retarding, right? If I am told to calculate the deceleration here, it is the opposite of the acceleration. It is the opposite of the acceleration, which means it is negative here, right? So it is important to know the motion of the graph from here to here to here. And we can see that this shape is trapezium-like, right? I may cut my shape like this, so that this may be a triangle, this may be a rectangle, and another triangle, or I'll just look at the shape as a trapezium in general, right? So we can find distance under the graph. From this graph, distance under the graph is equal to the area, right? We can find the area of this triangle plus area of this rectangle plus area of this triangle. That is the distance. Or I may just find the area of the whole trapezium. Area of a trapezium is equal to half a plus b times h, where a and b are these parallel lines. From here to here, I may take this side as my a, then from here to here is equal to this distance from here to here. So these two parallel lines, I may call this my b, and h is the value which will be here, right? So this will be my h. It is the same, zvakafanana kutsvaga distance ye trapezium, area of a trapezium nokuita this area plus this area plus this area. This is what we can do. Then from here, let me rub here, we may find acceleration. Acceleration, this is the rate of change of velocity. So it is calculated like this: v minus u over t. V, this is final velocity, where pana h pano, this is our v, our final velocity, and here it's our u, initial velocity, and time taken from here to here. We can find our acceleration by saying final velocity minus initial over time taken, or we may use the formula of gradient, you know, y1 minus y2 over that formula of g of gradient, because acceleration tukuchaka pa slope, right? Saka with this unokwanisa kurova traveling graph rako pa examination rako, right? Let us put an example. GNG, General Next Generation. We continue. The first question, find acceleration in 8 seconds. Right? Acceleration, we say A is equal to v minus u over t, where force is our v, force minus and our u, 0 is our u, our initial velocity, and 8 time taken to reach 40. So over 8. So it will be 40 over 8, which is 5 meters per second squared. So this is our acceleration. Acceleration is measured in meters per second squared. Meters per second squared. Then from here, we can be asked to calculate acceleration in the last 4 seconds. Last 4 seconds from here to here. We can also use the same formula. Acceleration is goes final minus u over t. What is our final velocity? 40 minus initial, 0 over time taken. What is the range here? It's 4. So we say over 4. So 40 minus 0 is 40. 4 into 40 is 10 meters per second squared. That's our acceleration in the last 4 seconds. Then we can be asked to find the total distance. In 20 seconds. So total distance in 20 seconds. Distance is area under the graph, right? Area under the graph. What is the area of this shape? Area of this shape. Area of this shape. Then we add. Area of this shape is going to have base times height plus of this shape is equals length times width plus of this shape half base times height, like this. So half, what is our base? It's 8 times our height, it's 40, right? Plus what is our length? Length times width, right? Here from 8 to 16 there is 8 times, then 40, right? This is a rectangle. Then plus half, what is our base? A range from 16 to 20, or can we say 20 minus 16 is 4, our base, times our height, which is 40. So 2 into 2, 1, 2 into 8, we get 4. 4 times 4, get 160, plus 8 times 4 is 320, plus 2 into 2, 1, here is 2, 2 times 4 is 80. 2 times 40 is 80. So we add all these things, we may get 560 meters. This is the total distance traveled. Or we may use another formula looking at this shape. This shape is a trapezium. The area of a trapezium is equal to half a plus b times h, which is half a, I may take from 0 to 20, which is 20, plus b, right? The distance between these two parallel lines from 8 to 16, from 8 is same. So plus 8. Plus 8, then times our height is 40. Then I cannot say 2 into 20, 2 into 8 here because we are adding. But we can say 2 into 2, 1, 2 into 40, we get 20. Or I may firstly add 20 plus 8, then I get 28, then I put 2 there. So 20 plus 8, I get 28. 28 multiplied by 20, I may get 560 meters. So, right, G and G, given this diagram, guys, then our first question may ask us to find acceleration in the first 8 seconds. So the formula is the same. A is equals V minus U over T. Our final velocity is 9 minus our initial 0 over time taken 8. So 9 over 8. Our acceleration will be 1 and 1 over 8 meters per second squared. This will be our acceleration, right? Distance in 14 seconds. Calculate distance in 14 seconds. Distance, remember, is area under the graph. I may use this shape and this shape, right? Let's just go. Half base times height plus length times width. So I may say half 8 times 9, then plus length times width. What is the difference here from 8 to 14? That's 6. 6 multiplied by 9. Right, like this. So 2 into 2 here. Here we are able to say 2 into, because there's a multiplication sign here. 2 into 8, we get 4. 4 times 9, 36 plus 9 times 6 is 54 plus 54. Our average distance is 90 meters per second. Right? Or I may use the area of a trapezium because this looks like a trapezium. This looks like a trapezium. So area of a trapezium is equal to half A plus B times H. Now, half A, I may take from 0 to 14, half 14 plus B, the distance between these two parallel lines, which is the same. So 14 minus 8 is 6, times my height, it's 9, times 9. So here, I will say 14 plus 6. This is the easiest. So it's half 20 times 9. So 2 into 2, 1, 2 into 20 is 10. 10 times 9. Then I may get 90 meters per second, which is the same. So then, given that the average speed, this is our question. It's just freestyle, guys. Our average question, given that our average speed is equal to 7 meters per second, find the value of t. Now we really know that speed is equal to distance over time taken, but we don't have this distance from 14 to t. But if you look at this shape, this is a trapezium, but a trapezium is upside down. Trapezium akafongora hiyo. Toita say nayo, saka tutanga tachaga area of this both chart area of pano patachaga plus area of this trapezium. So what will be the area of this trapezium? It is the same half A plus B times H. But the difference is this one. Our A and B in this time will be 9 and 7. Whatever chawada kutora. So it will be half 9 plus 7 times our H, and our H will be the distance from T going to 14. So it will be T minus 14. So 9 plus 7 is half. 9 plus 7 we get 16. T minus 14, 21. 2 into 16. What do we get? We get 8. 8 times T, 8T. 8 times 14. 8 times 14, 8 times 14, 8 times 14. We may get something like 112. Is it 112? Right? 112. So, our distance here is 8t minus 112. Then what was our distance here? Our distance here was 90. So we may say plus 90. So what is our final distance? 8t. So minus 112 plus 90. We may get something like minus 22. We may get something like minus 22. This distance we calculated, which is 8t minus 112. Then we may add 90 so that we may get the distance of this whole shape. So it will be minus 112 plus 90. We get something like minus 22. So we go back to the formula. Speed is equals distance over time taken. Then we are given that the average speed is 7 meters. So put 7 here. Is equals what will be our distance? Our distance is 80t minus 22. So, right? Over t here. T for time. Right? You are going to find t uyu ndiye achatipa the value of this t. So multiply both sides by t here by t. So t kuno anobva afa. So it will be 7t is equals to 8t minus 22. Then GLT we group like terms. Then 80 will come here. It will be 70 minus 8t is equals minus 22. So 70 minus 8t will get minus t. So minus t is equals to minus 22. Divide both sides by minus, cha. So our t is 22. T is equal to 22 seconds. So here is 22 seconds. Right, GMG, right, given this diagram, made bit over times z. Calculate acceleration in the first 4 seconds. Acceleration is equal to v minus u over t. Right, our final velocity is v squared minus u. It's 0 over time taken 4. So it will be 20 over 4. And our acceleration is 5 meters per second squared. Right? Then we may also be asked to calculate the total distance traveled in 15 seconds. Remember distance, that's area under the graph. Area of this shape plus this shape plus this shape, which is half base times height, plus length times width, plus half base times height. Half base times height is half. What is our base? 4 times our height, 20, plus length. What is the length from 4? Range from 4 to 10. 6 times 20, like this. Then plus half base. What is the base? The range from 10 to 15. It's 5 times our height is 20. Right? So 2 here is 2. 2 times 20. It's 40 plus 6 times 20. It's 120. Plus 22 here into 20. It's 5. It's 10. 10 times 5 is 50. 4 plus 50 is 90. 90 plus 120 is 210 meters. This is the distance. We say distance, that's area under the graph, or we may use the area of a trapezium half. A plus B times H half. What is our A? From 0 to 15. And B, the distance between these two parallel lines from here to here, here to here is the same. So I may say 10 minus 4, that's 6 times my height, which is always 20. So 22 here, 22, 20, it's 10, 6 plus 15, it's 21 times 10, it's 210 meters, right? So it is just the same. Let us say, guys, given that, okay, we may be asked to calculate the average speed in the last 4 seconds. Last 4 seconds, maybe somewhere here. 11 here. So last 4 seconds ranges from this. So first of all, I am going to find the gradient from here to here, right? Gradient from here to here, gradient is equal to acceleration. So what will be my gradient? Formula y1 minus y2 over x1 minus x2, right? I'm going to pick coordinates. This is the x coordinate here, going here, so x is 10, and this is the y coordinate. When x is 10, y is 20, right? Then here I am using the first triangle, guys. Here x is what? Is 15. What will be the value of y? Remember the law on a Cartesian plane, along the x-axis. When x is 15 here, y is 0. So y is 0. Saka here the coordinate of y is equal to 0. So on my gradient, these points ziripadenga ndopanenge pana x1 y1, ziripazazi ndopana x2 y2, right? So y1 is 20 minus y2 is 0 over x1 is 10 minus x2 minus 15. So it will be 20 minus 0. What do we get? 10 minus 15, get minus 5. 5 here, we get minus 4. So acceleration or the gradient is minus 4 meters per second squared. Now, if you look carefully, we want to find the velocity here of this second triangle. So what is the formula for velocity? V is equal to u plus AT, right? And V is because U, my initial. Patangira mota yangu kudropa ichiuya kuno. The initial V was 20. So 20 plus A is the acceleration I calculated minus 4 multiplying by time. Which time yandotora? From 10 kusvika patatangira kubata 11 seconds pari kutangira 4 seconds, which is 1 second there. So my V will be 20 minus 4 times 1. It's minus 4. So V is equal to 20 minus 4. Okay, 16. So here my V is 16. Right? Allow me guys to rub here. Just allow me to rub here. So it seems like we have now two triangles like this. This 10, 15 with 20, and this with the 16, 11, and 15. Right. So the question is saying, what is the average speed in the last 4 seconds? So in the last 4 seconds. So the formula for speed is equals distance over time taken. Now, how do I calculate distance on a triangle? That's the area. So what is the area of this triangle? I am going to say half base times height over 4. Right? So this will be half base round from 11 to 15. It's 4 times height. It's 16. Right? This over 4. So this will be 22. 1, 2 into 4. 2 times 16. This will be 32 over 4. 4 is for 4 seconds. So this will be 4 into 4, 1 into 32 is 8 meters per second. So the average speed is 8 meters per second. PNG, welcome to Sewila Sejedza. Right. Looking at this graph, it's another type of speed time graph. Right? Tikatarisa, this is initial velocity. Object yedu yatangira pano iyo. Yao yapana bandika. So this V stands for the final velocity. It's like this is the value of V2. This 50 is the value of V1. Right. And this 5 here, the 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 20, 25. So, time here say panap. Its average, its speed is equivalent to V. 7 is equivalent to V. 8 equivalent to V. 9 equivalent to V. 10 equivalent to V. Because panap, that it's a constant velocity. It's a constant E. It's a constant velocity. So from this question, we may be told that this object decelerates at 4 meters per second for 5 seconds. Decelerates at 4 meters per second for 5 seconds. For 5 seconds, it decelerates for at 4 meters per second. The object decelerates at 4 meters per second for the 5 seconds. For the 5 what? Seconds. So, what is the speed at 10 seconds? So, which means 10 is somewhere here. The speed, so it will be the same, the value of V. So, equation is tricky bits. I need to get 10 seconds, even like 17 seconds, even like 16 seconds. It will be the same. So, right? Kanataka piwa deceleration. Anilika? Kanataka piwa deceleration. What will be our acceleration? We have deceleration. So which means the acceleration is negative. Because acceleration is the opposite of deceleration. So my formula is like acceleration is equal to, I may use V2 minus V1 over T2 minus T1, right? Which is change in speed over change in time, right? And change in speed over change in what? In time. So what will be my acceleration if I'm given the deceleration? It will be negative. My acceleration will be negative. Like this graph, this is my acceleration. What will be my deceleration? It will be negative. And then they go right. Second, so here is equal to, so who is my V2? My V2 is this. So I will say V minus my V1. V1 will be 50. So 50 over right? Our time is what? Is 5. T2, T1 is 5. Right. Our time is 5. From 0 here, from 0 to here. It's just, this is T2, this is T1. So it's 5 minus 0. I may get 5. So from here, I'll cross multiply. This is over 1. So 5 times negative 4, we get negative 4. Negative 20, I may get negative 20. Which is because 1 times V is V. 1 times negative 50 is minus 50. So from here, I'll group like terms. U minus 50, we are both angale. So it will be minus 20 plus 50. Plus 50 is equals to V. Because number I put accent, change sign. So minus 20 plus 50. Unechikwere changu che 20 dollars 1 per 50 ndokuzosera mari 30 is equals to V. So the value of V here, velocity in 10 seconds will be 30. Will be what? Our velocity will be 30 meters per second. This is the answer. That's how we get it. Then from here, distance. It is just the same. You just start the shape. You can see this is a rectangle. This is a rectangle. So I may use this rectangle to calculate the first. So what is the formula for rectangle? Length times width, right? Plus the shape of this triangle. What will be its base? Its base is like here to here. That's the base. So here is 5. And what will be my height here? Is my height is from V this to 50. So I may say 50 minus V, which is 30. So my height will be 20. So plus half base times height. Then I get the answer. Right, it will be. So what is length times width? Length is 25 times my width is 30. 25. What is the value of 25 times 30? 25 times 30 plus half. What will be my base? Is 5 times. What will be my height? Is 20. 5 times 20 like this one. 25 times 30. What will be the answer? It will be 750. Something like 750 plus 2 into 2 here. 2 into 20. We get 10. 10 times 5. This will be 50. So 50 plus 50, something like 800. So 800 meters. This will be my distance. 0783996222. We say Jeza, say Willa. Distance and traveling crafts.